Let's talk about combining forces. Before we do that, we first have to define what a net force is. A net force determines whether an object moves and also which direction it moves. So in this example, we have a picture here of a person kicking a soccer ball. The input force would be the force applied on that ball, which is 10 newtons, and the output force is the result of the input force, which happens to be 10 newtons as well. And to determine the net force, we would have to look at the output and the input force. So we have 10 newtons of input force moving in one direction and 10 newtons of output force moving in the same direction. And what we do is we add the two up because they're moving in the same direction, and we get 20 newtons. And notice that the arrow is actually 2 times longer. The 20 newton arrow is longer than the 10 newton arrow, and which makes sense because 20 newtons is larger than 10 newtons, therefore the arrow would be longer. And notice that the arrow is moving to the right. That's because the two arrows, 10 newtons and 10 newtons, are moving to the right. Therefore, the net force would also be moving in the same direction. Now, let's take another example. Let's say that there was 5 newtons of force applied on an object, and there was a force that was playing a role that's actually slowing down the movement of that object, such as friction. And so there was 10 newtons of output force. Because the two arrows are moving in the opposite direction, we would have to subtract 5 from 10, and what we get is 5 newtons. However, the direction of the arrow is moving from right to left. That's because the 10 newtons is larger than the 5 newtons, and so the direction of that movement of the 10 newtons will actually supersede that of the 5. That's why the net force is 5 newtons moving from right to left. Let's do another example. 5 newtons was applied, a force applied on an object, and there was 5 newtons of force on the opposite direction. And for this, because they're moving in the opposite direction, we would also subtract, and what we get is 0. But ask yourself this question: which direction would this object be moving if the net force was 0? In fact, that object is actually not moving, and so if you get a net force of 0, that object does not move because there's equal forces being applied on the input and the output force. So let's talk about balanced and unbalanced forces. In balanced forces, there are equal forces that are acting on an object in the opposite direction. So if we looked at that, if we go back to that same problem in the last slide, the force that had a net force of 0 would actually be a balanced force because there's equal forces acting on one object and they're moving in the opposite direction. And I'll refer back to that in a few minutes. An unbalanced force is whenever there's a net force acting on an object. So every time you get a net force, not a net force of 0, but every time you get a net force, that is an unbalanced force. So let's go back to that slide. So let's look at the first problem. We have a net force of 20. Would that be balanced or unbalanced? That actually would be unbalanced because we have a net force. It's the same thing with the second problem. It's also unbalanced because we have a net force. And the last problem, we have a net force of 0. Anytime you have a net force of 0 with the two forces moving in an opposite direction and they're equal, it actually is a balanced force. And that's how you combine forces.